Hello guys. Wait, did I call you guys? Sorry. Hello freshers. Yes, you guys are still freshers. Good morning, good afternoon, good evening, or depending on what time you're watching the video. But I want to believe it's in the evening. And if I'm correct, send me a 10 kwacha. I'll drop my line at the end of the video. Yeah, so my name is Mr. Mateo. I'm your base 140 tutor under IIA CBO chapter. That's the Institute of Internal Auditors. So if you haven't subscribed yet, please do make sure to do so. You are missing out on a lot of opportunities, trust me. So today we're talking about a certain topic called logarithms, right? I usually have challenges pronouncing this word. Yeah, I'm hoping I'll get used. So today we're talking about logarithms, yeah. And this is a topic which you did in grade 12, so won't even waste much time on it. So it's a build-up topic from a certain topic which you learned called indices and exponentials. So if there are any principles which you've maybe forgotten under that topic, I would advise you just quickly revisit it and then come back, right? So let me just be quick to mention that the reason why you got introduced to logarithms, it's because you've got topics coming ahead your way which will require you to apply the properties of logarithms, right? So if you thought you've gotten done with this topic, then you might have to maybe think again. So before we even begin, let me just make mention upfront that it's usually important, like I usually mention, always try to get the concept of each and every topic right. Set the foundation correct, all right? Understand the topic to its fullness, because it's only that way that you will be able to answer a question, no matter how much, Mr. Mvula tries to dance around a certain topic or a certain question. So get the foundation right, and then you are well and good. All right, so let's look at the first principle. So we'll look at different properties of logarithms, and then if you get them correct, if you're able to, master them correct and apply them, then you're home and dry. So let's look at the first property. The first property states that the logarithm of 1 to the base of any number b is always equal to 0. This means that if you've got maybe logarithm of 1 to the base 100 to the base 1000, the answer is always 0. By base, I mean, have you seen where the b is? Whatever number which is usually placed there, it's what we call the base, right? So let me show you some examples, right? So the logarithm of 1 to the base 100 is equal to 0. The logarithm of 1 to the base xy is also equal to 0. The logarithm of 1 to the base 99 is also equal to 0. Whatever the base might be, if it's the logarithm of 1, the answer is always 0. All right? So please don't forget. Let's look at the second property. The second property states that the logarithm of a number b to the base of the same number again b is always equal to 1, right? The logarithm of a number, for example 2 to the base 2 is always equal to 1. Let's look at some examples. Alright, so the logarithm of 2 to the base 2 is equal to 1. The logarithm of x to the base x again is equal to 1. Have you seen that logarithms are simple, right? I'm sure by now you're even deliberating the topic, that you can even get 100% under this topic. So let's look at another property. Yeah, property 3. So the logarithm of a number b raised to the power x to the base, the same number again b, is equal to x. So the x there is what we call the index, right? So log b to the base b, like we said here, log b to the base b was equal to 1. So even here, the logarithm of b, even though it's raised to a number x to the base b, it's equal to 1. We'll just bring down the x, all right? So x multiplied by 1 is equal to 1. So that's the understanding there. So we've got an example below. The logarithm of 10 raised to the power x to the base is equal to x. So if you've got a log of a number and the base is not given, if it's empty, where there's usually b, there's nothing, always assume that the base is what? Is 10. If you haven't been given the base, always assume that the base is what? Is 10. So the logarithm of 10 to the base 10, have you seen that the numbers are, the same? So log 10 to the base 10 raised to the power x is equal to x, right? So that's pretty simple. So I wanted to show you guys this. Maybe it can help you to understand this topic a bit. So when you're given, for example, you can punch on a calculator, just punch the logarithm of 1000, your answer will be 3. So like I said, if you haven't been given the base, always assume that the base is what? Is 10. So if, for example, the base is 10, right? The logarithm of 1000 to the base 10. The understanding there is, in fact, what they're asking you is how many times can the base 10 which is here, how many times can 10 be multiplied by itself to give you what you have there, 1000? And the answer is what? Is 3. Okay, so if you multiply 10 3 times, you get 1000, or simply 10 to the power 3. So that's the understanding, right? Let's look at another principle or property, property 4. So if you've got a number b raised to the power log of another number x but to the same base, have you seen that the b's are, the same? So the answer again is equal to x. You just bring down the x, right? So that's the understanding. If you've got a number b raised to the power log of another number x but to the same base again, just bring down the x, right? That's the understanding. We've got an example below. So we've got 2, which is raised to the power log p, which is another number. We don't know what p is, but the base is what? The base is 2. So they will just cancel out and then we'll bring down the p. So whatever p might be, but that's the answer, right? Let's look at another property. I want you to pay attention here, because that's one of the properties which usually got me confused come grade 12. All right, so you've got b raised to the power y equal to x. So the expression which you have here is what we call an exponent. It's in exponential form, right? The y is what we call the index, the b is the base equal to x. So the exponential form here, what you have here, the b, the y, and the x, can be written in logarithmic form by saying the log of x, the x here, it will be log of x, and then the b will be the base now. The log of xb equal to y. All right, please understand this. This is the another way which the exponential form here can be written as a logarithmic form. So you can even convert what you have here again in logs to this form. Just say x equal to b, and then the y which is here, just raise it up. Okay, it will be x equal to the base b and then raise the y up. Let me see if we have some examples. There we've got some examples. So if you have a number 2 raised to the power 3 equal to 8, and then you've been told to express this exponential form in logarithmic form, so what you do, you just say it's log 8. So say log 8, the 8 here, which doesn't have an index, you say log 8 to the base 2. The 2 which is here, it becomes the base equal to 3, right? So again, the understanding is, in short, very kupshati, how many times can 2, the base here, how many times can 2 be multiplied by itself to give you 8, right? And if you multiply 2 3 times, it will give you 8. 2 times 2 is 4. 4 times 2 is what? It's 8. That's the understanding. Hope get the concept right, guys, okay? Yeah, let's look at some further examples. So supposing you're given that log of x to the base 2 is equal to 3, find the value of x. So instead of trying to start punching on the calculator, whatever, because you won't be able to find the value of x. So you just express it back in exponential form, right? And then say x, the x which is here can be written as x equal to 2. The 2 which was the base here becomes, more like the subject, x equal to 2. And then the 3 which was here, you just raise it up. Like I said, you raise y up. Even here, you raise the 3 up. So x equal to 2 to the power 3, which is equal to 8, right? So in short, they are asking you how many times, like what number can be given if we, what value will you get if you multiply 2 3 times? And the answer is what? Is 8. So the x there is actually 8. Okay, let's look at another example under the same property, just maybe to help you understand. Okay, so we're starting from here. We already dealt with the one on top, the example on top. So let's look at the another example down. So here you've got x as a base. So log of 9 to the base x equal to 2. Find the value of what? Find the value of x. Upon sure we've even started, shaking when there's actually nothing difficult here. So what you do is you just express it back again in exponential form. That's all. You say 9 is equal to x raised to the power 2. That's all. And then now you have to get rid of the 2, the index here, because you want the value of x alone. So what do? You can square root both sides, or you can just simply multiply the powers by half. And why are we multiplying by half? It's because we want to get rid of the 2. So we multiply x to the power 2 by half to get rid of the 2. And then we even multiply also 9. We'll multiply it by half to get 9 raised to the power half, right? So here we'll have x equal to, now remember 9 can also be written as 3 squared. 3 times 3 will give you 9, so that's basically one and the same. So 3 raised to the power 2, and then we multiply by half. The same thing which we did to x, we did to 9 again. And then it will be 2 times what? Times half. What you have there, 2 times half, and then the 2 will just cancel out. You remain with the 3. So meaning your value for x will be x is equal to 3. That's the understanding there. Let me check. We have another example. All right. So the logarithm of the square root of x minus 9 to the base 3 equal to 2. The question then is, find the value of x. It looks complicated, but basically there's nothing difficult here. Again, just express it back to what? The exponential form of it. So you say what you have there in the square root, just say x minus 9, square root x minus 9 equal to 3, which was initially the base. It will be equal to 3, and then the 2, you raise it up, it will be 3 to the power 2. So 3 raised to the power 2 is 9. Same thing, you just bring it down. X minus 9 equal to 9, and then you have to get rid of the radical here. Now how do you get rid of the radical? You just multiply by 2, because this is the square root, right? So you multiply by 2 equal to 9. So even there, what you do there, you also have to do to the right side. So you multiply by 2 to get rid of the radical. Even to 9, you multiply by 2. You get x minus 9 equal to 81. How did you get the 81? We said 9 times 9. 9 squared is same as 9 times 9. You get 81. So we want to find the value of x, so we have to get rid of the negative 9. So we just take it back. You cross it to the right side, it will be 81. Since it has changed the sides, it was negative, it will become positive. X equal to 81 plus 9, and the answer there is 90. 81 plus 9, that's 90. Let's look at another property. If you've got the logarithm of two numbers being multiplied by themselves, the logarithm of a number m being multiplied by n to the log b. Now, this can also be written as log of m to the base b plus log of n to the base b. Now, they were initially being multiplied by themselves, and the rule here states if you've got two numbers which are multiplying themselves, they can also be written in this form. But since it's multiplication, the sign will change to be what? To be positive. I'm sure you remember this, right? So don't forget, the logarithm of two numbers, maybe x, y, being multiplied by themselves, and then you want to find maybe an independent value of x, you just say logarithm of x to the base b plus logarithm of y to the base b, and then you find the corresponding value for y or for x. So yeah, let's look at an example. So supposing that the log of 8 to the base 2 is equal to 3, and log of 7 to the base 3 is equal to 4, and logarithm of 7 to the base 2 is equal to 5. The question is, evaluate log of 56 to the base 2. So what do? You've been given those values on top, and then you have to evaluate log of 56 to the base 2 using the information which you've been given. Let's see how we can tackle this question. Yeah, so that's the question. Let's check out the solutions. So log of 56 to the base 2. Now 56 can further be, I don't know if factorized or broken down. 56 can be broken down by saying 8 multiplied by 7. The dot in between is symbolizing multiplication. So 8 times 7 will give you 56. So there's basically nothing which has changed there. And the reason why we're multiplying by 8 and 7 is because these are the two values which have been given on top. I know there are many factors for 56, but we have to look at the information which we've been provided with. So the logarithm of 8 multiplied by 7 to the base 2. So now let's look at the information which we've been given. So like we said, under the same principle, we said if you've got two numbers multiplying themselves, they can further be broken down by saying log of number, log of 8, for example, in our case, log of 8 to the base 2 plus log of 7 to the base 2. And then you now go back to the information which you are provided with. Now remember, the first one says suppose log of 8 to the base 2 is equal to 3. So where we have log of 8 to the base 2, we'll just put what? 3. And then, so here, you've been given log of 7 to the base 3, it being 4. And then you've also been given log of 7 to the base 2 equal to 5. So you've got two 7s, log of 7 but to the base 3, and also log of 7 to the base 2. So which one do you go for? Right? So the multiplication rule is only applicable if the bases are equal, right? If the bases are equal. So in our scenario, we'll get log of 7 to the base 2, not log of 7 to the base 3, because here we have a 3, here we have a 2. So the multiplication rule is not applicable. So I just put this log of 7 to the base 3 to just try and maybe, confuse you here and there. So log of 7 to the base 2 here, we said what? The question said it's equal to 5. Please don't pick this one because the bases are different. So you go for this one over here. So since it's 5, you just substitute, say 5. So 3 plus 5 will give you 8. So therefore, log of 56 to the base 2 is equal to 8. So yeah. Let's look at another principle. So the logarithm of two numbers being multiplied, the logarithm of two numbers being divided by themselves, a number m divided by n to the base b can also be written as the logarithm of m to the base b minus Have you seen? Now it's minus instead of plus. Minus logarithm of n to the base b. So if they're being divided by themselves, the division will change to what? To subtraction. And then the number which is on top, you always have to start with the numerator, okay? Start with the numerator and then subtract by the denominator. Okay, please don't forget. So this is the seventh principle. Two numbers being divided by themselves. The log of those numbers, so just say log of the number on top minus log of the number which is down. Let's check out one example. So write the logarithm of 3 to the base 2 plus log 4 to the base 2 minus log of 24 to the base 2 as a single logarithm. So what do? Okay, see here. So these are the numbers which have been given, and then you've been told to express these numbers as a what? As a single logarithm. So what do? So you've got two numbers, right? The logarithm of 3 plus 2 is being added by logarithm of 4 to the base 2. So this can further be written as, remember the product rule which we initially talked about. So if this is what we have, meaning they can further be factorized. I don't know what term to use, but we can put them together by saying logarithm of these two numbers, we just multiply them together. So it will be 3 multiplied by 4 to the base 2. And then we say minus, now we just bring this down. Logarithm of 24 to the base 2, we bring it down like that. So now we've got two values. We've put these two values together to come up with one value. And then we have now another value here, or expression. So now here we've got a subtraction sign. And then from this row which we learned here, remember, two numbers being divided by themselves, the sign will just change to become subtraction. So then in this form, we have to convert them back into this form here. So here, so then this form, we have to convert them back now. So what do? We've got the bases are equal, so the division rule is applicable. So we just say the first number, it will be 12 divided by 24, and then we'll say logarithm of those numbers to the base 2. So logarithm of 12 divided by 24 to the base 2 will also be simplified further by saying, because 12 into 12, that's 1, and then 12 into 24, that's 2. So it will be logarithm of 1 over 2 to the base 2. So that's your answer as a logarithm, but this can further be simplified by saying logarithm of 1 over 2 to the base 2 can further be written as the logarithm of 2 raised to the power negative 1 to the base 2. That's basically one and the same, right? And then remember now what I said, if the logarithm of a number to the same number again is actually equal to what? To 1. So just bring down the negative 1 to be negative 1 multiplied by 1. So your answer is what? Negative 1. But if you've been told to express as a single logarithm, just end here, okay? But if you want to find the value, then you can proceed up to here. Okay, so let's look at the final property now. It's concerning changing bases, right? You might be given a situation where you've got two logs, a certain log to the base of another log, and then another log again to the base of another log. So yeah, so how do you change the bases? So if you've got the logarithm of m to the base b, and then you want to change to base a, what do? So you just say the log of m to the base which you want, which is a, and then you divide. Don't forget, you divide, you don't multiply. Just divide again by the logarithm of the initial base. Your base was what? Was b. So it will be the logarithm now of b to the base, your desired base. It will be log of b to the base a. So the bases must be equal because that's what you want. And then just take care of the m and b. The m will maintain it, and then on the denominator we have to change the m. It will no longer be m, it will be b, the initial base. So if the base was maybe 2, so even the b here will be 2. Let's look at an example. The logarithm of 7 to the base 3, and then we want to change what we have here to base 5. So what do? So you say the logarithm of 7 to the base 5. So I said the 7 won't change on the numerator, so it will be log of 7 to the base 5, which you want, and then you divide by log of, it will no longer be 7, it will be 3, your initial base, which is 3, it will be log 3 to the base 5. So that's what you do. Basically that's it for now. We'll have another session. I will talk about the logarithms of natural logs, and then we'll also try and attempt some test 2 and test 3, or maybe possibly sessional papers and logarithms like that. So thank you so much for watching up to the end. My name is Mr. Mateo, and that's my line over there. You can contact me. It's on WhatsApp. If you have any query, any challenges anywhere, it might not be under this topic, any other topic, I'm available to help you out. Yeah, I might be busy here and there, but I'll definitely make sure to respond within 24 hours, unless if I'm like really busy. Yeah, so if you want to make payments again, if you want to subscribe to IIA, please do make sure to get in touch with me. Thank you so much for watching. Take care.